Hey, ProbStats kids, this is Dr. Callahan with week 13 Friday. Go ahead and pause the video and answer the following 3 questions for your warm-up. All right, let's go ahead and move on forward. Just to put things into perspective so that way you know what is going on here. This week is week 13. Next week is going to be week 14, and your finals going to be on week 14 or 18. So there will be 4 weeks before your finals. All right, when I saw you guys last class, we had an assessment on week 13 Thursday. So if you have not gotten to that yet, make sure you check out the MS Team. The assignment is posted on there, and it's 7 questions, multiple choice. And so today we're going to go ahead and continue talking about the area underneath a normal distribution. So we're going to talk about 5.2, find out the probability of a normal distribution. We're going to go over 3 steps using the plus and minus table, so you need that. And we also need 2 colors and a calculator. And then afterwards, I have a little bit of a card practice, 6 problems, 2 points each I'm going to have you guys work with. And your homework tonight is going to be number 8 all and number 18 all. All right, so turn over to page 6. Go ahead and read the objective for today. There are 4 of them. All right, so area, probability, and percent. With a normal distribution or any continuous distribution, the probability of getting a value greater or less than x is equal to the area of that shaded region. The area and probability are both expressed as a percent, and it's usually always 100%. And you move the decimal 2 times to the left to change the value to a decimal. Or if you want to change it to a percent, you move it 2 spaces to the right. So then looking at this bell curve, remember the U is the mean, this little squiggly little circle thing is the standard deviation, and the formula that you use to find the z-score is this formula right here. Up to this point, I always gave you guys the z-score. Well, you guys are big boys and girls and you're super smart, and so now I'm going to have you guys find the z-score using this formula. So the 2 things you need are the mean, the standard deviation, and then a value of something like a shoe size or somebody's height or somebody's test score. All right, so let's go ahead and take a look at this. To find the probability with the normal curve when given an x value, there are 3 different steps. Step number 1, you want to go ahead and draw a diagram. So there's my diagram right here. Then you're going to go ahead and transform the x value to a z-score. So we're not quite there yet, so let's go back to step number 1 and read the example. It says, a survey indicated that people use their computers on an average of 2.4 years before upgrading to a new machine. Okay, so an average means average is 2.4. The standard deviation is 0.5. A computer owner selects a random. Find the probability that he or she will use it for fewer than 2 years before upgrading. Less than 2 years? Oh my goodness, that's actually not a lot of time. So let's go ahead and take a look at this. Okay, so the probability is less than 2 years. So when I go ahead and draw this, this is going to be your mean. Your mean is 2.4 years. And then you're going to have your standard deviation. And so then 2 years, if the mean is 2.4 here, means that 2 years, and let's say that this right here is, this is the mean. So then at 1 standard deviation, minus 1 standard deviation, it will be 2.4 minus 0.4. I'm sorry, minus 0.5, which will give you a 1.9. So 1 standard deviation is going to be 1.9. So you want less than 2 years. So yours is right here. This red line right here represents 2 years. So if you want the area less than 2 years, it's going to be on the left side of this. So we're going to take a look at this area right here. This is what we're trying to find. Okay. All right, so step 1, draw the diagram. Done. Step 2, transform the x value to a z-score. Okay, your x value is going to be 2. X equals 2 because you want to know how long or what percentage it's going to be if it's less than 2 years. So then I'm going to go ahead and find that z-score, which is going to be x minus the average divided by the standard deviation. And if I plug that in, I'll have 2 minus 2.4 divided by 0.5. So grab your calculators and tell me what that's going to be. You should have a negative 0.80. Okay, so what that means is that right here at 2 years, your z-score is negative 0.80, and you need to look this up on the table to determine the percentage. So then let's take a look at the table here. Here's my table. Negative 0.8 is going to be right here. 0, 0, so go all the way down. So this is your answer right here, 21.19%. And that's exactly what you have. Remember, it's always from the left to the right, so this area is 21.19%. So the question says, assuming that find the probability that he or she will use it for fewer than 2 years before upgrading, they will probably use it 21.19%. So then use a table or calculator to find the probability of area. Well, there you have it. That is your percent. So what are the chances of them to use it less than 2 years? It's a very, very low percent. Most people probably use it more than 2 years. I mean, I've had this computer for probably 4 years now. So, yeah. All right, let's take a look at question number 2. Go ahead and read it. All right, so for question number 2, it says a survey indicated that for each trip to the market, a shopper spends on an average of 45 minutes with a standard deviation of 12 minutes. So the average is 45 minutes and a standard deviation of 12 minutes. And I believe that because when I'm in the grocery store, if I'm there by myself with my kids, I probably spend there for about an hour. But if I'm there with my kids, I'm like, I am in and out of there in 20 minutes because I don't think I want to stand in a grocery store with 4 little ones. The length of time spent in the store is normally distributed and represented by variable x. A shopper enters a store. Find the probability that they will be in the store between 24 minutes and 54 minutes. So 2 different questions. So let's go ahead and draw this. So here is my mean, which is going to be 45 minutes. Okay. At -1 standard deviation, you are going to have 45 minus 12, which is going to give you a 33 minutes, okay? At -2 standard deviation, it is going to give you a okay, I don't know why it's doing that. Okay, that was just weird. I don't know why I did that. But anyways, at -2 standard deviation, it's going to be a 33 minutes minus the 12, which is going to give you a 21 minute, okay? And then at +1 standard deviation, it is going to be 45 plus a standard deviation of 12, which is 57 minutes. I can stop right there because if you look at it, I want 24 to 54, and that's within the range of what I have right there, okay? So let's go ahead and do the following. Draw and label the curve, which I did. find the z-score using the equation. So I'm going to have to find two z-scores. The first one is going to be z-score 1. So you're going to do 24 minus the mean, which is 45, divided by the standard deviation, which is going to be 12. Z-score 2 is going to be 54 minutes minus 45 divided by 12. So what do you have for both of those z-scores? The first one that I have is a negative 1.75, and the second one is a 0.75. So put that into perspective. A negative 0.175, if this is a negative 2, it's going to be like right here. Z-score equals negative 1.75. And then a positive 0.75 is going to be right before the first standard deviation right here. So that's z equals 0.75. Okay, so now let's go ahead and take a look at the table. So the first one is negative 1.75, so the negative 1.75, and if you look at it, it is at 4.01%. So 4.01% is where you are. Let's go back to it. So that is telling me that from this part right here, this piece right here, it is 4.01%. Okay, that little space right here. Okay, and then let's take a look at the second one, which is 0.75. At 0.75, it's right here and here. I'm going to go down and over. That percentage is 77.34. So 77.34 is this entire region right here. So that is 77.34. Okay. Now remember, you just want that little region in between them. So that little region in between them is this green area right here. So what percentage is that going to be? And remember yesterday when we talked about if you have these two numbers, and in this case it is 0.04 and 77.34, how are we going to find that green region? Remember we said how we're going to go ahead and subtract them? Yeah, so you're going to take 77.34 minus 4.01, and you're going to get a 3, a 3, a 3, and 7. So your answer is 73.33%, and that is the green region. So find the probability when a shopper will be in the store between 24 to 54 minutes. That's 73% of all shoppers, which is a big percentage of all shoppers, majority of them. If you're an outlier, I guess you could be the other 27%. That's going to be there less than 24 minutes or more than 54 minutes, which I'm like, I might be that person being there for 60 minutes as an outlier, just so I don't have to go home and deal with my kids. But yeah, and just enjoy my sweet time doing whatever at the grocery store. All right, example 3. Find the probability that the shopper will be in the store for more than 39 minutes, okay? So once again, we're going to go ahead and draw this. So here is your mean. Your mean is 45 minutes. At -1 standard deviation, the reason I'm going over to the left side instead of the right side is because 39 is less than the mean. So at 1 standard deviation, it is going to be 45 minus 12, and that's going to give you 33 minutes right there. So 39 minutes is going to be like literally right here somewhere. Okay, and that's 39 minutes. So then find your z-score. And so your z-score is going to be z is equal to 39 minus your mean divided by your standard deviation. So grab your calculator and figure out what that's going to equal to. And it is going to give you a negative 0.50. Okay, so the z-score at negative 0.50 is going to be probably right here. Okay, So z equals negative 0.50. Now I want to figure out, because it says more than 39 minutes, well, this is 39 minutes. More than 39 minutes is going to be this area right here. Okay, since it's going to be on the right side, let's figure out what the percentage is and then take 100% minus the whatever percent 0.50 is. Okay, so then let's take a look at that table, which all of a sudden it disappeared, but that's okay because I am going to find it. So let me find my table. Here it is. Let's copy it over to this question. There we go. I want to make sure that we're still on the same screen. Okay, so we are. Okay, so then looking at the screen right here, you want to look for negative 0.50. So negative 0.5 is going to be right here, 0. So that's your percent right there because that's 0. Okay, and that is 30.85%. Now remember, this is always from the left to the right. So this right here is 30.85%. So I don't want that white shaded area. I want this orange shaded area. So what is my strategy? What do I need to do to go ahead and find that? Well, what you're going to do is you are going to take 100 minus 30.85%, and that is going to give you a 69.15%. So going back to the question, how many percentage of people spend more than 39 minutes? Like about 70%, which makes sense. I think most people spend probably more than 39 minutes at the grocery store, like me, unless of course I have my 4 kids with me. All right, you guys, so that is the 3 examples. And let's take a look at example 4, because it seems like I have one more. Okay, so example 4, if 200 shoppers enter the store, how many shoppers would you expect to be in the store for more than 39 minutes? Well, last question, remember, it's more than 39 minutes was 70, or actually was not 70%, it was 0.6915, or 69.15% of people spend more than that time. Well, if there are 200 shoppers, how many of those 200 shoppers will spend more than 39 minutes? So you want to take that decimal and times it by 200. So once you go ahead and multiply by the 200, you should get 138 shoppers who will most likely spend more than 39 minutes in the grocery stores. And that is it. All right, so next what I want you guys to do is take a look at this worksheet here, okay? So I would like you guys to go ahead and, using the X, find the z-score, draw the diagram here. So that's your first task. And then when you're done with that, I want you to estimate the z-score using the z-table and finding the area underneath the bell curve for these 8 problems. Third thing I want you to do is a gratitude thing. This is today I am grateful for, and give me 3 things. And the last thing I want you to do is, it says Thursday, Friday, Monday, Tuesday, Wednesday. Give me your goals for the next week, for week 14. I want you to list 1 thing that you would like to accomplish each day for next week. All right, you guys, that is basically it. I hope you guys are having a good day. And as always, stay safe and healthy, and I'll see you guys next time. Take care.